Nice to be here. There, sort of, something. So thank you for inviting me, Stanley, and arranging everything. So today I'm going to, well, let me see here. I need to share my screen, but before I do, I need to start a slide deck. Okay, now. Okay, do you see my slide deck? Everybody good?
Yes.
Yeah.
Yeah.
Okay, good. So this discussion has a lot to do with, basically everybody's rethinking, the big legacy systems, the monolithic systems. And I try to create in this talk some perspective around why that should be done and the care that has to be given to it. And also ask the question, are microservices the ultimate answer? But what I want to do is, just put a focus on the word thinking. Because what I find is that everybody wants the re part. You know what I mean? They want the re-implementation, the re-architecture, the everything new, but the thinking part doesn't always happen. So let's talk about that. I'm the founder and chief architect of this open source project. It's a platform called Vlingo, and it works for Java and .NET, so C#, generally speaking. You can find out about it at vlingo.io. And this is a reactive platform. So I'll talk a little bit more about this through the discussion for you this evening, and maybe we'll have some time for questions about that later. As Stanley mentioned, I'm the author of these 3 books. I'm also on the board of directors of the Reactive Foundation, which is part of the Linux Foundation. And recently I was commissioned by the publisher of my current 3 books, or I should say previously published 3 books. And now I have a signature series. So I'm working on that. I'm currently working on a book with a co-author. And we actually, the 2 of us have 3 books planned. But we already have about a dozen other authors who would like to have their books published in our series. So you'll see these streaming out over, the next 6 months to a year time frame. Hopefully, our new book will be announced before the end of the year. Okay, so let's talk about this subject. Microservice, right? Everybody's going microservice. But what does that actually mean? What is a microservice? Have you ever heard things about, trying to define the word micro in microservice, right? What does micro mean? Does micro mean a lines of code count or some other logical thing, or is it just a deployment strategy? What is the micro part of the microservice? Maybe we should just call them services, but we kind of got in trouble 10, 15 years ago with SOA, right? Service-oriented architecture, and also at that time even service wasn't well defined, so it caused a lot of confusion. But does it mean that everybody is going microservices, so we should go microservices? Is that what we should be doing? So I want to just make it clear that we are software developers who, generally speaking, work for businesses who are not in the business specifically of developing software, right? The business might be, I guess in Singapore is a lot of financial work, right? And maybe some other kinds of startups are happening in Singapore, just some things around high tech. So what's big right now? Anybody want to volunteer? Like what kinds of businesses are hot right now in Singapore?
Well, shipping has always been hot.
Okay, shipping.
Tech.
What is it?
Fintech.
Fintech, yeah. So banking, equities trading, right? Things like, or foreign exchange, things like that, right? So the point is that the business is in business to make money, right? That is the thing. And so, you know, the business just wants to roll around in piles of this stuff, right? That's that's what makes them happy. But what makes us happy as software developers? Does this, you know, disorganization of the money make any of you feel uncomfortable? Like it's just like sort of like, wait a minute, for us, right? How much money is there? And actually, you know, the business could look at it and go, it must be billions. And we look at it and go like, how would we ever count that? You know, so this is more what we want, right? and so does this mean microservices? You know, that we want microservices to make money like this? Well, let's talk about it. So I think what we need now are some definitions around this topic. So let's get some definitions. First of all, let's define legacy as this, right? It's money, because if legacy didn't support money making, it wouldn't be legacy. It would be turned off, right? It would be unplugged. That, right? Because how does that saying go? Old software never dies, you have to kill it. You know, so we, right, if this was a really bad deal for the business, they would just say, get rid of it. You know, and that's sort of happening now. A lot of businesses are saying, wow, these legacy systems are actually costing more than they're helping, because, you know, we can't innovate in these messy systems. Releases are happening too slowly. They're too risky. It's too risky to make a new release quickly because we don't know what's going to break when we make some change somewhere. And so, you know, the legacy money makers are also problems. Now, I just want to make a comparison here that there are two kinds of legacy systems. This is a legacy monolith. And I'm showing this specifically to emphasize that monolith in itself does not mean something bad, right? If you had a legacy system that sort of had this, you know, conceptual architecture, it would be pretty great, actually, because where we actually are is more like this, right? This is the typical legacy system. And when people say legacy and they mean it in a bad way, right, negative, this is what they're talking about. The BBOM stands for big ball of mud, right? You guys know that term already? Big ball of mud. So, you know, in thinking back to this previous slide, you know, what's the difference? Well, let's count them. We have 7 major modules inside a monolithic container of some kind. So this container might be a JEE container. It might be, you know, some Windows executable. you know, 7 different DLLs, right? Or however you want to think about it, it's a way to put different pieces of the software into different places, right? So let's just start off with that definition. This is monolith, and this is big ball of mud monolith, right? So it doesn't necessarily mean the same thing. Okay, anemic domain model. I have to say, I don't even like using the word domain in with this expression, because typically what this actually means is data model. And it's a data model that has been represented in a high, you know, in a high level language or a general purpose programming language. And it's anemic because it has no real well-defined behavior. The behavior is only a matter of literally setting data into properties, which in effect is setting data into columns in a row in a database table, right? That is literally what most, when we hear the term domain model, that is mostly what that means today. And this is a problem because the anemic model, as I said, looks like this. Now think of this client concept, right? So we have in the business, we have some concept that we know as a client, and the client means something, but we're not sure exactly what, because when we look at the client, it's mainly just this. A client has an ID, a client has a name, a client has an address 1, an address 2, a city, state, or province, you know, a postal code, and it just keeps going. Now we can well imagine that, you know, we're only looking at what, 6 or so properties here, or attributes, but this class probably has 30, 40, 75 attributes in it, right? You've seen these entities, right? It's an entity, and this literally means that if I have 60 fields or attributes in this client class, it means that I have a corresponding 60 columns in a database row, right? In a table, probably called client or clients. And so we mark this this is Java, so we have an annotation entity, and we have an annotation ID, and an annotation column. This could well be in C#, right? It would just then be square brackets around it, and but it would be the same kind of thing, only called an attribute, not an annotation. But the point is, think about just instantiating this object. How would you do it? Well, typically, this object wouldn't have a meaningful constructor. It would just have a 0 argument constructor. And here's how we refer to it these days. We new up, right? We new up the client. You ever hear that? Why? It just means that we create a blank object that has no initial definition at all. It's just a bunch of nulls, essentially, right? So we new up this object, and then we have a bunch of setter, you know, it's not even expression, it's an operation, right? It's saying set the ID, set the name, set address 1, set address 2. Now, if you did have a constructor, or even the service that takes the parameters for this client, if you had to take 60 string parameters into a method, just think of the complexity of doing that. And you know, if you did this initially from a form, you know, a web form in a browser, how would you do that otherwise if you literally have 60 different pieces of data that you have to set on this client? It's very error prone, because you could very easily, you know, confuse address 1 and address 2. Just maybe you're in a hurry, or maybe there's another kind of name below, like something name, or first name or last name or something like that below, and maybe those become confusing concepts because you do have very many attributes to think about here, or fields. So that makes it very difficult to deal with that kind of model. Okay, what is a microservice now? Is it 100 lines of code? So the person who takes responsibility or credit, if you will, for defining what we today call microservices says that a good microservice is about 100 lines of code. And I'm wondering, what does that mean? Does that mean 100 lines of Java or C#? Because those are fairly, I think C# would tend to be less lines of code just because of the getter setter on a property, right, is just implied now. Or very simple, get set. So, it could be that's what that means. But if you're in Java, then maybe it's only 50 lines, right? Because you have the double number of lines of code for the getters and setters, or even triple. But if you're working in Clojure, you're writing a microservice in Clojure, 100 lines of Clojure is a lot more than 100 lines of Java, right? As in, you can do a lot more in Clojure in 100 lines of code. Okay, so boy, trying to measure the size of a microservice in these terms is a little bit difficult. Like, okay, should it actually be 400 lines of code? I've heard people say it's actually 400 lines of code. And then others say, no, it's 1,000, right? It's 1,000. But think about the actual problem that we face with these kinds of definitions. So 100 lines of code microservice. What does that look like? So notice here that I have in the center some sort of topics. And let's say that this is Kafka. It has to be Kafka because that's the only kind of messaging we can talk about now is Kafka, because it's super popular. And if I were to say anything other than Kafka, you might think, wow, that Vaughn guy, he's really not in the modern times here, but let's just say it's Kafka. And then you have these little 100-line microservices around, and you're asking, well, why does he draw those like they're little balls of mud? Well, you'll see in a moment. But what happens is all these little 100 lines of code microservices have to talk to each other in some way. So we can either create a network of REST interfaces, right, between them, or we can have everything push stuff on a message bus, and then they can just read what they want to, right? Any of those kinds of things are problematic, actually, because what if certain pieces of data are secure and should not be read by certain microservices? Well, then we have to have multiple topics. Okay, how many topics, right? And which ones have what level of security? And so this, is a problem where you start looking at, you say, well, okay, we have about 35 microservices here, not too bad, okay? Now, over time, you keep adding microservices, and then you start to ask a question. If we were to unplug, right, undeploy like this microservice at the lower right-hand side, kind of, if we just took one of those and said, does anybody still use that? It looks like there isn't much traffic going to that lately. We haven't actually seen it handle a message in a week. Does that mean it's not used anymore? Oh, but wait a minute. What if it's only used once a month? Or what if it's only used biannually or something like that, right? Oh boy, we have a bit of a problem. What are our dependencies, right? So if we were to unplug that, will we break something that we won't even know that we've broken until months from now, maybe? And so we say, what should we do about this? And so the same person that defined 100 lines of code as a good size of a microservice also says, here's the answer. It's only $400 a month to keep every microservice running that you ever created. So if you create a microservice, plan on never shutting it down, because it only costs $400 a month, and therefore you don't have to think about it anymore, right? Now, okay, we're happy about that, yes. And then, right, a few months later, this is what it looks like. And we have more topics. And now you know why I drew little balls of mud, because actually this is one big distributed big ball of mud, right? That's what it is. Because you have the same problem with this system that you have with the monolithic system, where you're afraid to touch anything because you don't know what the consequences are of unplugging even one of these things. And so you stand back and you simply say, don't touch it, right? Don't change it, because we don't know. So what we'll do is we'll just keep adding more and more microservices, and those microservices will compensate for whatever other thing may happen over here. We'll just sort of say, we'll take this as the new outcome and sort of ignore the previous one, right? Do you see the problem here? This is really, really problematic. Because here's what you end up with, right? It's not just the complexity of the microservice. Think about the expenses too, trying to run this, even in the cloud. So how many here have ever worked on a system that's like 1 million lines of code or more? Anyone? Yeah, sure. I mean, I've worked on 1 million lines of code system. 2 million, sure. I don't know, 5 million, that sounds like a lot, but there are plenty of systems out there that have 5 million and more millions of lines of code. So let's just take, right, like thinking in terms of a complex system, let's just take first 2 million lines of code and ask a question. What does that look like in terms of 100-line microservices? Well, this is what it looks like. 2 million lines of code divided by 100 is 20,000. You would have 20,000 microservices. How many here can keep more than 5 to 7 things in your mind at one time, right? Not too many of us. Some may have an upper range of 9 or 10. That's a really special person. And others are like maybe 4 or 5 even, you know. Now, here's something we can understand, is that 20,000 microservices times $400 a month is $8 million a month. That's something we can all go like, oof, that's harsh. And then over 12 months, 96 million, right? And then, you know, just start increasing that. For 5 million lines of code, that's 50,000 microservices, that's 20 million a month, that's $240 million a year. I am pretty certain that that would get the attention of any CFO in Singapore, right? Any CFO that sees that kind of thing crossing their desk, they're just going to go, there is something seriously wrong here. And that's even if it lives long enough for the developers not to completely give up and say, wow, 50,000 microservices, what have we done here? And let me give you an example. Did you see a tweet maybe 6 months ago about this Monzo bank? Someone tweeted about the Monzo bank, and they were really happy. I would say that this was a bragging tweet, saying, look at what we have done. We have created a new online bank, right? It's a digital bank, and it's only 1,600 microservices. Well, no, they actually said, and it's 1,600 microservices. And I have to say, right, this is kind of a cool picture. If I were to print this and put it up on a wall, even in a frame, it would be pretty cool. And people would ask me, what is that? Is that an abstract? Is that some kind of new abstract art? And I would say, no, it's a bank. You know, they're like, what do you mean it's a bank? Well, it's just the network connections between all the microservices in a bank. And people would be like, do they really do that kind of thing? And I would say, well, Monzo Bank does. And they go, how does it work? And I go, I'm not sure. And I would even say, how do they know that it works, right? How does the bank know that this works? This is only 1,600, 1,600. Wait until it reaches 10,000 microservices, right? 20,000. You think that won't happen? I think it will, right? Monzo Bank, if they stay in business, they're going to just keep doing more and more banking types of things, and this will just continue to grow. Can you imagine, like, trying to deal with this level of network connectivity between all these microservices? How would you know that it works? And you know what's really scary to me? What's really scary is these dots, these nodes or services on the right-hand side of this that have no lines going to it. Do you see that? That's where I'm actually worried the most. I'm like, wait a minute, why are there no lines going over there? I would be worried about asking why not. You know, does that mean something should be running that isn't? Or are those things that got decommissioned? And right, this is the kind of problems that we run into. Okay, so I think you got a bit of a picture there on the whole microservice thing. Now, reactive. What is reactive? Well, reactive is, you know, primarily these kind of like 4 characteristics, and mainly message-driven. So reactive is a message-driven architecture, and you can add to that event-driven. So it is event-driven, but you think about events as messages. Okay, they're a kind of message. And so underlying all of this is message-driven. And then message-driven also gives you the ability to be responsive because of the elasticity, where you can expand and contract your scaling for a given, you know, solution or system. The message-driven part of this makes that possible. So then, as you go under heavier load, you elastically expand, you know, the number of compute nodes that you are using, and so you stay responsive. And then, what if any problems happen? Reactive has these sort of built-in and even necessary concepts called supervisors, generally speaking. And a supervisor is necessary actually within message-driven, because you don't have the same kind of call stack that you have in a typical blocking, you know, programming language. Like if you're using C# or Java, you just keep calling deeper, right? Down the stack. And if something happens down here, and you throw an exception, it will, you know, if it's not handled somewhere down here, it will bubble up, and then you'll have this, you know, a handler up here somewhere, hopefully, or something just logs the exception. Whereas with message-driven, because there's a disconnect between the sender and the receiver, you don't have the same kind of call stack. And so this actually gives you an opportunity to watch for a kind of crash that might happen in the system and take care of that very specific kind of crash and help the system to recover from it. And also it becomes a bulkhead for not causing, cascading failure. So reactive has a lot of advantages in that way. And a reactive service, its architecture can be this simple, where you literally have a set of port adapters on the left-hand side. Let's call it a resource here, like a resource handler, like a REST resource, where you have an incoming HTTP request, or this resource could be a message handling resource, and it takes whatever input it has and turns that into a command that the domain model can handle, and it gives it to, let's say, an actor here, using the actor model. And so when it gives that command to it, the actor model only handles one message at a time in an entity. And so this entity just deals with one concept at a time, and it says, oh, I'm going to handle this command, then I'm going to handle this command, then I'm going to handle this command. And on each of those, it emits an event, let's say, and that gets persisted. This is called event sourcing, right? This kind of model that we're looking at here, or the persistence mechanism that we're using. So in reactive, we can really shrink down and simplify our architecture. Now, if you've been dealing with really complex architectures for long enough, when you used to think that was cool because you got to conquer it, now you're just like, okay, I'm over that. I just want things to be as simple as possible, because then I'll have more assurance that they actually work. Reactive also provides the idea of reactive streams, and reactive streams gives us these four components or concepts. One is called a publisher and a subscriber, so pub-sub, right? We're familiar with that, and a subscription between those two. And then we have an additional concept called processor, which is actually both a publisher and a subscriber. So it's a subscriber first because it sees something coming in from a publisher, and then it does some sort of transformation inside, and then the processor then becomes a publisher of that transformed element or set of elements into a new kind of element, into a different stream. And reactive streams also has this powerful concept called back pressure, which means that the subscriber can tell the publisher how much data or how many elements it can handle at any one time. So it's actually forcibly, telling the publisher, don't give me too much. Or, well, it is always saying never give me too much, even though its request limit may be infinite, which means I have no, upper bound, so to speak. And so it would be roughly impossible for a publisher to give me too many things. But the point is that this is a protocol established between the subscriber and the publisher, with the subscriber saying, I can only deal with this much. And this is really important in streaming, because you can very, very easily overwhelm a subscriber and blow up their queue, or whatever it is, that the mechanism through which they are getting data. Okay, so now, have you noticed that I've spent about half my time in the talk just talking about technology type things? What about the business, right? Again, right, if we long jump, right, you remember that from C, the days in C, long jump. So here we are in our stack, and we long jump all the way back to that slide that had the pile of money. That's where we really should be, right? Solving problems for the business to help the business make money. And the more innovative we can be in doing that, the more chances the business has to make more money, okay? And I have to say, just talking purely about money and business doesn't make me that happy, but it is what businesses want, right? Look up the definition of corporation. Corporation means an entity like a person, and that entity exists to make money, and that's the definition. So, even if our desires as developers are more around the cool tech stuff, this is the kind of problem that we actually really have to solve. So here's a communication style in a corporation, in an organization, that I would call the strategic wall. And this is actually typical. This is the norm. This is where you have executive management, right, up here at the top. And depending on whether or not you're a startup or a large corporation, let's just say that there are between 2 and 20 levels between the executives and the software developers, right? You know what I'm talking about? Somebody, does that make sense? Yeah, and actually 20 may be conservative. I've consulted and taught at companies that have 50 layers. So many layers that nobody in software development has any concept of what it would be like to talk to one of those executives. They're not even in the same country, right? They're in a different nation or different nations. And so they kind of look at the problem that they face because of this, and it's overwhelming. Because what happens is, by the time you boil this kind of communication structure down, how many levels of communication do you have that causes filtering and redefinition and translation into something else? So by the time I, as a software developer, receive some sort of information about the software I need to implement, this becomes a very, very unclear message, right? And that's just simply because of the number of layers. Now, have you heard of Conway's Law? Conway's Law, right? Now, what I would say that most people say about Conway's Law is that Conway's Law means, because I have 3 teams here, I'm showing 3 software development teams, and they're all working on the same system, we will tend to have a system of 3 subsystems, right? That's sort of what most people say, correlate and say, okay, because Conway's Law says an organization that creates systems is constrained to create systems that reflect the organization's communication structure. And so the communication structure is seen as, we have 3 software developers or 3 software development teams here, therefore we will have 3 subsystems in this common system that they're working on. And while that may be true, and probably is in a lot of cases, we're only considering one small part of the communication structure. What about the other 2 to 20 layers or levels above them? This is all part of the communication structure and has a positive or negative impact on the software development. And I have to say, with even 2 levels of communication, right? What are the chances, or 3 levels of communication, what are the chances that this product owner at the top of the team circle, right, or oval, that the product owner or the project manager is conveying accurate information to the software developers? Have you ever played the telephone game? I think maybe you've heard of it. I don't like this name, but I'll simply tell it as a familiarity. Don't they call it Chinese whispers? Have you heard of that game where someone whispers in your ear and you have to tell the same message that they tell you to the next person in their ear, and even 2 people conveying, right, this message to this person, then this message to this person, it becomes confused. And by the time you get through 10 people, you've got a completely different story on the other side, right? This is why I call this a strategic wall, because the communication structure is broken before you even get started. So what do we have here? I call this a strategic gate, because what we're doing is moving the business visionaries and the software developers into a lateral communication where we are talking directly to the people who are responsible for carrying the vision forward. And now we literally have a one-to-one communication between these individuals. And this is not telephone. And I have to say, even just the communication directly between two people can be complex, because the business mind has one model in mind, and the software developer is trying to map that into their world. And just that single level can be complex enough to deal with, and therefore, right, don't add any more layers to it. This is as good as it's going to get, generally speaking. The only thing that we can improve on in this situation is more talent on the business side and more talent on the software development side. And that's really, and talent may mean better communication skills, right? Just better listening and better explaining, right? So back to this. Okay, so how do we measure a microservice and the size, or what does a microservice mean now? Okay, what if it means this? We have strategic communication or conversations, and we simply put a context around that specific communication, and we call it a bounded context, right? This is what domain-driven design calls a bounded context. And the communication that we have within this team is called the ubiquitous language. And so what we're going to do is create a context within which this team of business people and software developers have conversations, and we're going to say, okay, let's lock that down into an area called a model, and we're going to model our software according to the way that we speak as a team. And any documentation, any diagrams that we draw, any other kinds of communication that we have between people, including our software itself, will use the same nouns, verbs, expressions, and so forth, right? And therefore, this is what we come up with, is the bounded context. And so each bounded context that we have here represents a different area of expertise in communication, right? That is literally what it means. And so how many conversations do we have here? Somebody want to tell me quickly just how many conversations, how many different, I don't mean single conversations, but, boundaries of conversations do we have? It's 7, right? It's 7, yes. And so, oh, do you remember where we saw 7 before? Well, let's hold on to that idea. Here's something that we have to overcome. Our conversations that we have as software developers with the business have to go beyond the ordinary, right? Most of the software that gets created today does not go beyond the ordinary business process, but it stops short instead of seeking strategic advantage. So one of the things that we can do is communicate better in our model. So before we were looking at an anemic model, and now we're looking at a intention revealing model, a model that has rich behavior and well-named behaviors, so that when we say client relocate to postal address, wow, doesn't that pack a bit of power right there? Doesn't it? Because it really just tells us, and even in a way that the business can understand, that a client can relocate to a postal address. And so this actually, putting these concepts into a language like we have here, actually a very simple language, but nonetheless a language, helps us to reason about the software and what it does. Also, just to make a point, notice that we no longer have those potentially like 60 different attributes or fields just hanging out there on the client. Instead, what the client has is just a few concepts that are crunched down into what we call value objects. And a value object as a postal address and a value object as a telephone number are these places where we put these attributes that are cohesive and have, right, like they belong together within a whole conceptual component, and we just put those together, and we even make them immutable so that we don't have to worry about if something changes in one of them, how might that break something. So we've really taken some powerful, ideas and simply put them into this software. You know what's really cool about this? There's way less lines of code here in this, what you see here, than there is in the Anemic model. And you can test it. Think about, again, just picture 60 different fields or even 30 different fields, and the number of permutations that you can set values on any of those strings and how many ways you can get it wrong. You literally cannot test for correctness in that. You could write 100 tests, and you would still not have any idea if it works. So what you have to do is you actually have to move the test up and make it an integration test, because all that you can test is that the database columns and rows and columns get set with the data that you expect them to. And so you're actually testing generally 3 layers instead of at least 3 layers instead of only 1, or even just 1 unit. And now notice the power here too, right? Relocate to, we can set a postal address and emit a domain event. And this event can have an impact on the downstream, where the downstream can be notified that a client relocated. So let's say that the client, here's a scenario, the client just ordered something with e-commerce, and that e-commerce product is going to be shipped out, and just before this, just after they placed the order, they remembered, oh, I changed house, right? I moved house. I need to go update my postal address. And they relocate to, and this relocation, right, sends an event downstream that affects the shipping department, and the shipping department says, okay, right, or the fulfillment department, and the fulfillment or shipping department says, okay, we can now ship this to the correct location. So very powerful concepts in 3 lines of code. Isn't that cool, right? So now, again, think back to that 7 module monolith. What if the 7 modules represented 7 bounded contexts? This means that even in a monolith, we can have an organized set of conversations between developers, 7 different sets of conversations between business people and developers. And we have a loose coupling between each of these conversations, sets of conversations, saying, if you want to send, if you want to have a conversation with any of us inside here, you got to go through our translator. And because our translator is going to put things in our language that were in your language, or it's going to make you put your language into our language, right? And this is, the kinds of things that you see with domain-driven design. So you have to think of DDD as being very much conversation-driven, language-driven, okay? Now, how do you get from a monolith to a microservice? Well, if you got this monolith on the left, you are in really good shape for moving to microservices. Because notice, it's not that some oddball object in one of these top, you know, one of these modules at the top of the monolith has a direct link or reference into an object in one of the other modules. No, you can't do that, right? This is like, we're back in school. No, you can't do that. You have to talk through the communication channel between major modules. Now, if we simply take those 7 major modules and move those into a microservice each, now what you have to do is you have to introduce the network, but you can now introduce the network through, for example, a set of topics, or even through REST, because the REST interface could represent the topics anyway. It's a protocol, but the established architecture for exchanging communication between these microservices becomes a lot easier to deal with. Okay, so now getting from the big ball of mud to microservices, okay, this is more challenging. And so, you know, how many companies in Singapore still have a lot of COBOL running? I'm guessing a lot of them, but maybe I'm wrong. Maybe they're fortunate enough to be newer banks and not the banks that we have here in the US and Europe that are just jammed full of millions upon millions upon millions, you know, no doubt billions of lines of code across many banks, right, in COBOL. What you have to recognize about this situation, if you face it, is that you got to rewrite this stuff, because the people who wrote this have great grandchildren now. Okay, they don't want to write COBOL code anymore, if they're even still alive. Okay, I mean, seriously, I'm not trying to be disrespectful in any way. I am just telling you that from a business standpoint, this is a very bad investment to be in right now. And so you got to find a way out of that, because even whoever you license your mainframe from, or your supercomputer, or whatever they call it these days, you know, Z something or another, it's all the same model. It says that, you know, these mainframe companies, did I say IBM? And then they even tell you what software you can and cannot run on those. You actually do not own the machines. They own them, and they just lend them to you for a really, really expensive, you know, price tag every year. And then, right, they even tell you, no, you can't run that software there. You can only run software that we say you can run on it. And by the way, we sell that software to you too, right? I mean, you know, I can think of some mobs that aren't as well, you know, put together as that. So here's where you have to go from the monolith to get to the microservice. Is, I think that your best shot at this is to try to create a well-modularized monolith first, from the big ball of mud, one byte at a time. And if you ask a CIO or a CTO, give us like 3 months to clean up this monolith, you're probably not going to be granted that time. And even if you do, you'll probably fail, right? Because the monolith will continue to change. The big ball of mud will continue to change, and you'll be putting out fires in the big ball of mud and not getting much work done over here. And so what you have to do is stamp out one little fire at a time. And that's going to happen when the business says, we need this change in the big ball of mud. Then you're going to make that change along with some restructuring or you know, refactoring, and you're going to start modularizing and breaking these pieces apart a little bit at a time. Now, I know the developer and the nice neat stacks of money, you know, in all of our brains says, no, we got to get rid of this big ball of mud fast. The problem is, it's taken decades to get here. You just cannot erase it overnight, or even in 90 overnights. You know, it's just not going to happen. So there are some ways you can get through this, and I'm not going to linger on this because this is a whole topic in itself, but the Strangler pattern is where you take little bits, but you're actually creating microservices one at a time. So this is different than that 1 byte at a time. This is more like 100 bytes at a time or something like that. And there are different ways to do that. You can use change data capture through products like Dependencies or Oracle Golden Gate or whatever. Or you can restructure. Maybe you say, okay, let's take our current anemic model and let's start splitting apart the idea of commands go over here, right? Things, when the user says do this, right, then those kinds of things go over to the anemic model, and then we create a different anemic model for the query part, and then we can mostly take the hit in the UI at first. And what I have seen is in legacy big ball mud systems like this, even in COBOL systems, the business has changed the user interface many times, as in even the technology used, from, you know, Flash, Flex, from green screen, right, to PCs, to Flash, Flex, Angular, Vue, React, right? They've gone through these changes over time, and they're willing to take the hit in the UI. It's the whole tearing the mud apart, you know, boxing up the mud, that becomes really complex. So you can take these restructuring steps and break things apart. And then as you break them apart, you can better identify where your microservices are and still use this CQRS pattern. And look, okay, you're sharing databases for a while, but you got to take initial steps. If you don't do this, you know, database sharing for a while, it's just going to be fraught with error. But finally, you get to this restructuring stage where you've taken, right, you've taken sort of these really big bites at different layers, and finally you've separated the databases into command and query models on each of the microservices. So that's another way to kind of think of this problem potentially. Now, in terms of efficiency, and I'm going to wrap up here very soon, but I'm coming to you all the way from the United States, so I can go a few minutes over time, right, Stanley? So Forbes ran a survey about 3 years ago, and they calculated in this survey, you know, with different CIOs and CEOs saying, how much money do you think you're wasting in the cloud? And it was about 30 to 35%, you know, they were spending too much money in the cloud. Because why? Well, because you don't understand, again, like everything that's running. And so expenses start to run away with you because you can just commission this new, right? You can just commission this new server or, you know, set of servers or whatever, and it gets expensive. So part of this problem is just the efficiency of software. And I like this quote from Dave Farley. He said, I can't think of many other fields in human endeavor where a 50 times loss of efficiency is acceptable in exchange for ease of use. And what he's talking about here is Python. And wow, I may have just stepped on some toes, right? Oh, there are people who love Python. And I'm not talking against Python, but all that I am saying is, pardon me, in the big picture of software development, if everything that we were running across the globe was running on Python, we would be in really bad shape, because we would be taking hits of about 50 times the amount of overhead processing power. And that, what does that mean? It means just multiply the number of nodes in the cloud, or you can make it whatever you want to, right? Just multiply those, and the efficiency is driving cost up, okay? And so you know, Donald Knuth said this, and this is where our little Vlingo, you know, our little tiny Vlingo Twitter account said, quoted, you know, quote tweeted Dave Farley, but then added this quote from Donald Knuth that said, people who are more than casually interested in computers should have at least some idea of what the underlying hardware is like. Otherwise, the programs they write will be pretty weird. What are the programs like that we write today? The programs that we write today are generally blocking, very inefficient, even using slow runtimes. And we even cause ecological problems due to this. As Dave Farley says, right, if you could do in 1 millisecond, if you could do something, compute something in 1 millisecond, but it takes 1 second to do this, that's actually 1,000 times CO2 emissions because of that. The 1 second versus 1 millisecond, right? And he says, okay, that's insignificant for one application, but at a global scale. Now, add money to that, right? Just think in terms now, even if we were to say, heck with, you know, CO2 gases, we don't care about that. We'll let our grandchildren deal with that problem and the global warming and whatever. But let's just think about money right now. Well, then I think you can figure that out as well. You know, if it's 1,000 times CO2, what's the monetary cost? So then this is where reactive comes in. Reactive comes in with being more efficient. And this is where the actor model, our little tiny Blingo platform that only takes about, you know, in its all its glory, right? Everything that it does, which is a lot, it only takes about 300 megabytes of RAM to run most systems, and maybe up to 0.5 megabyte. And we outperform, for example, Spring Boot by like 10 to 1. Okay, so just in a normal, you know, web request and so forth, and we'll be producing data on that soon. There's an experience report happening on that, and so, you know, efficiency matters, folks, and not compromising in the quality of your domain model is extremely important. And ease of use, as in lowering the overhead of the architecture and lowering the overhead even of the code that you have to write in order to express a domain concept is really important. And so, you know, I encourage you to look at reactive DDD, and you can do that through taking a look at the Blingo platform.